So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video. Okay, so the intro was like, wow, it's peaceful and it was quite melody, right? Wasn't that? Okay, and why was that? Because this video is not gonna be proving some like identity or solving any integral and solving any infinite product, solving any infinite sum, right? It's, you can say it's far more beyond that, or else it's far more lower than that, you can say. Because in this video what we're gonna do here is we're gonna talking about what is pi. What is pi? Wait, relax, everything is fine. Okay, what is pi? First of all, guys, I don't mind who you are, what you are. If you are a watcher, like maybe I just did use a wrong word, I think, I'm not sure, but if you're a viewer of my channel, so you might be have known, right? You might have an idea about what is pi, right? What you must have listened pi somewhere, right? So basically this is pi, right? Or sometimes we denote this something sort of that. So yeah, and now I'm just asking you, what is pi? For someone pi is 3.1415, and that just keeps going up to infinity for someone. And I'm just gonna tell you who is this someone. And for someone it's 22/7, although these two things are same, but yeah, for someone it's different. So who we are we gonna be talking about pi in this range only, or we gonna be like moving something sort of beyond these two things? And let me tell you, I have done my 12th this year, right? Although I didn't went to school in class 11th and 12th, I have done all the things by myself only. I'm passed. Okay, and I have studied in like till class till 10th in school, right? Regular classes. So when I was in 6th or 7th standard, I just got to know what is pi. So it was like, oh, what's this? What's this? It's just 22/7 and it's just 3.14. Let's just memorize it and yeah, that's it. Okay, so what's the area of the circle whose radius is 2 units? So it's just area is, let's say this is your circle and the radius is 2 units. So the area is 2 squared, 2 squared times pi, and it's unit squared, which is 4 pi. And we just have to multiply this 4 with this 3.14, so that's going to be giving us something sort of 12.4 and 16, something sort of that, unit squared. And they're done. And guess what? This thing, I have followed this thing till my class 10th. Let's just memorize this formula, even though there were a lot of questions in textbooks. They were like saying, or they were like you can say requesting us to use either this value or this value in order to get the perfect value. Whoa. So let's just don't talk about that. Actually, let's just not talk about that, because that's really I would say disgusting, because this is not the way we should study, right? Okay, and no, it's not ended till now. When I just got entered in class 11th, I just got enrolled myself into a coaching. Oh my god, I was a kid. I was a goddamn kid, right? Okay, so I just got enrolled in, myself into a coaching, and that coaching was for a competitive exam. And you know the condition, the situation of a competitive exam preparative coaching. it will like just like it will, it's a marathon, you can say. It's a race of horses. You don't need to just care about anything. You just need to memorize formulas, and you just need to put the values of these things, and you are done. You're out, and you are successful in that field. But it's not the way we should just it's my personal point of view actually, and I think it's perfect. And yeah, so yeah, that's all it was. And still, actually, you know what, today I just questioned that why pi radians is 180 degrees. Why do we consider that? Why did I consider that? That why sine of 180 degrees equals sine of pi radians, and that was equals to 0. Why? Right. Okay. So let's just talk about let's firstly just talk about pi, and then we'll talk about why pi radians is equivalent to 180 degrees. Okay. Yeah. I'm so sorry, guys, if I have wasted your few minutes in just boring things like I just spit out actually here. But actually, I'm so sorry, guys. You know what? I have suffered through these things. So I just need to tell you this because, okay, here in India, okay, I'm not gonna criticize it. It's all right. Everything is fine. Okay. So what's pi? What's pi? Guys, pi is an experimental value. Okay, now I'm just gonna well, I'm not gonna derive it, but I can tell you how you can derive it. The experiment, and this is the experimental value actually. Every one of you can find this by your own. Okay, so let's consider a sphere, a perfect sphere. Although it sounds like a perfect sphere, isn't it? Yeah, it's perfect. Wow. Okay. Okay. So this is a perfect. I'm so sorry. It's not perfect sphere, but it's a circle, right? Okay. Although sphere is the 3D form of circle, but it's alright. Let's just talk about the 2D form of sphere, that is circle. So we know that this is the midpoint. Let's consider, so a circle, every circle has a midpoint, to which if we connect this midpoint to a side, and we know that it's uniform, that if we connect this circle, this point to this side, so the length of this one would be equal to this one, although it doesn't seems to be, but it's all right. In perfect circle, you're gonna just see that truth actually. So let's consider that this thing, this length is known as a radius. So this is your radius actually. Let's just name it. You know, you're gonna recognize me because my name is Aman. So you're gonna say, yeah, Aman. So yeah, so you just recognize me. So that's why we're just gonna say that this distance is radius. So to recognize that distance that is connecting the center of the circle to one of the you can say the edge, right? Edge of the circle is recognized as radius. Okay, so that's radius. And if we just join this one to this here, like two opposite edges joining together, so this is also the radius, right? As well. And radius plus radius is known as diameter. And basically, look, this is your radius, this is your radius. So I'm just gonna denote a diameter as small d. So basically, and radius as small r. So basically, here we have d equals to r, right? Obviously, because if we just add these two radiuses, so that's gonna be giving us diameter, right? Okay, so far it's fine. Okay, now let's just talk about this part, that is the total arc, you can say, the length of the circle, right? So this is the length of the circle, which is often called as circumference or perimeter, right? So obviously, like, oh my goodness, I need to just have something Okay, wait a second, guys. I need to just find something. I got a coin here, and I'm just gonna use this for now. So, okay, I need to just come back to here. Okay, so this is a coin, right? Okay, so if we consider that it's a 2 rupees Indian coin, so if we consider that the center of this coin, coin is connected to the edge part is radius, right? It's R. So this is the center of this coin, and if you just connect a length, or you can say, if you talk about the length of between the center and the edge is radius. So if we just connect this another, like these two things, you can say this one and the opposite of this one. So that's going to be giving us the diameter, right? So this is your diameter, right? Okay. And if we talk about this part, like if we just anyhow measure the length of this, you can say the circumference, actually the length of this part, actually I hope you can just understand it. I'm just talking about this one. So again, this is being recognized as circumference, or you can say perimeter. Perimeter, right? So, okay. So every circle has that thing, right? Okay. And the experiment is, you have to measure the approx, like you just take a, not a coin, actually that's quite small, but a big circle, let's say. So let's say that this is a big circle. Can I have a circle here? Oh my goodness, why I'm having trouble. Okay, let's say I have a clock here. Okay, so yeah, that's gonna work. Okay, so this is your circle, right? Okay, so let's just consider this back over here. I need to, let me just explain it to you. So let me just draw this. Wait a second. Okay, so I'm just gonna draw this. Although it's not perfect because I'm having trouble drawing this, but it's alright. That's gonna be giving us a small, you can say a closed form, right? Okay, it's worse. Oh, okay, that sounds good. Okay, wait a second. So actually, it's a 3D clock, right? It's a 3D clock. Okay. So actually, this is the 2D form of this clock, right? So if we consider this, so this is your radius, right? And if we just consider this, adding this one as well, so that's going to be giving us 2r, which is d, which is diameter, right? So this is your diameter, right? Okay, and now what I was talking about the circumference is, look, so let's say that this is your center. Actually, I think this is the center. So if we just consider this one, let's say, so yeah, so this marker would be something sort of approx is the radius. So if I'm just going to add these two things from here to here, the length, if I'm just going to calculate the length from this point to this point, so that's going to be something that is the diameter, right? Okay, and if I just calculate the length of this part, that is this one, this part actually, right? So this part with the same like in the same you can say word, like inches, or in the same quantity actually I was talking about. So yeah, so okay, so we have the circumference, we have calculated that, and now we have also calculated the diameter. So let's say that we have calculated C circumference, right? So the circumference of that clock is C and the diameter is D. So the ratio of circumference and diameter is pi. That's the actual meaning of pi. Hey, wait a second, let me just check whether my video is, yeah, it's perfectly going on. Okay, so that's the actual meaning, or you can say the definition of pi. Like, isn't that amazing, guys? Look, just imagine a circle again. So just calculating this circumference and dividing it with the diameter of that circle. is giving us pi, which is 3 point, what is that? Wait. I just erased it, but yeah, is 3.1415. And that's gonna be giving us, right? It's sure. If you have just calculated everything perfectly without any kind of error, like a minor error could be, it's perfect, but not big error. That's gonna change the value drastically. So for that case, you just need to be careful about that, right? Careful about taking the measurement, right? So if we just took the perfect measurement, so you will see that the circumference over d, which is that diameter, would be exactly equal to 3.1415, and it's not just stopping here. Let's just see it going up to infinity. So that is really amazing. And guess what? This is valid for every circle in the world. Not world, but in the universe actually. Right? Okay. Now, I'm just gonna show you the beauty of the pi. That was really an amazing invention that humans could have, I would say. Okay, now let's just talk about the beauty of pi. Okay, so now you might be thinking, what, beauty? Okay, oh wait a second, what is beauty? Okay, so let's consider, okay, actually I need a perfect sphere, right? But I don't have right now. I'm so sorry guys, I should have prepared it for the video, but I didn't actually. Okay, but now I'm just gonna visualize you. I'm just gonna explain to you visualization. Okay, so let's just consider the earth, right? So earth is a sphere, but although it's not sphere, earth is, look, the shape of earth is known as geoid. Wait a second. Yeah, I think this geoid. It's not perfect sphere. It's not a perfect sphere because if we just look at the surface of earth, so there are mountains and there are patches like ducks, so there are some you can say, if we just empty all the water, so it's Pacific Ocean. So for that case, it's not a perfect sphere, you can say. But if we consider earth as a perfect sphere, right? Okay. And so if we consider the earth as a perfect sphere, so what's that's gonna be giving us? Wait a second, I'm just gonna tell you. Okay, so let's just consider again, visualize earth. So your earth, and if we talk about, let's say that this is your earth, let's say this is your globe, right? So the middlemost point, which will be having the highest circumference, right? Let me just take, I have a sphere, let me just take that for you. Yeah, I'm back. So I have a smiley ball actually. So let's say that this is your earth, right? Okay. So if you just take at this sphere carefully, so let's say this is your earth, right? So I'm talking, what middlemost point I was talking about is this one. I'm highlighting it. This one actually. Right? Wait a second. So this black point would be having, this is the middlemost point I was talking about, and this is the point where the circumference of this earth, or you can say this ball, is highest or maximum. Okay, and now why I'm considering this one only. Okay, let's say that this is your sun, right? This is our sun actually, not yours. Okay, so this is our sun, and rays are coming to earth. So if I assume that Earth is having a shadow of it, so obviously this middlemost point would be responsible for that, you can say, shadow, obviously, because light is not passing through this point, exactly this point only, right? The maximum, right? So I hope you all are understanding that. Actually, um, these things could be easily or very easily could be easily explained by AIs or some animations, but I have not access of that yet. But yeah, I'm not sure, but I would be having some sort of that. I'm just looking for that. So for that case, I'm just considering that middlemost point. Okay, so what's next? After considering the middlemost point, what's next? Okay, so let's just talk about what's next, because that's even more interesting, obviously. Okay. Yeah. So let's consider that the middlemost point. Middlemost point of Earth is this. You can say this point actually. I have just explained this out, or I have just made this out in such a way that we are just looking at the Earth from the top of it or from the bottom of it, right? Okay, so, and again, guys, you know what? When I was in ninth standard, there was a chapter named gravity, and gravitation actually in our science textbooks. So in that book, I just got a record actually. I was just got a data that the radius of Earth is not exactly actually, but it's around 6,400 kilometers. So yeah, I'm just going to consider that data, or you can consider R, simply R. Yeah, if you are not considering this data, then you can consider R. It doesn't bother us, because although it's impossible, but I think, I'm not sure, but yeah, it's impossible to just measure the radius of Earth physically, but yeah, so you can consider R as well, or more precisely you can say R of Earth. So this is the center of Earth, right? And this is your R of E, which is which we are taking as 6,400 kilometers. So again, that's going to be giving us 6,400 kilometers as well. So basically, the diameter of Earth, which is d sub E, is coming out to be 6,400 plus 6,400, which is 12,800 kilometers. Right? Okay, so that's the diameter of the Earth, of the place where we are living right now, of the planet on which we are existing right now. Okay, so this is the diameter, and so far we have we know about the definition of pi. Okay, so if we just plug this back over here, that is on the place of d in this equation. So pi is for the Earth, right? This is your Earth, right? So pi is gonna be c over 12,800 kilometers. And if we multiply both sides with 12,800 kilometers, so that's gonna be giving us the circumference of Earth, which is 12,800 kilometers, actually times pi kilometers. Without any physical, or you can say C of E is pi times R of E, right? For those who are not considering this thing, like just imagine that the condition applied for this thing is we have to consider Earth as a perfect sphere. So if Earth is perfect sphere, although it's not, yeah, just take a look at that. The planet on which we are existing, it's immensely big, that we cannot physically calculate even the radius of it actually. And from this discovery, from this very discovery, we can just think of the closed form of the circumference of the earth, and that is 12,800 pi kilometers. Oh my goodness, just take a look at this. The length of the middlemost point of earth is 12,800 pi kilometers. This is so amazing, guys, literally. Like literally, this is so amazing. So yeah, actually, so this was the first part of this video, that is what is pi. For what is pi, right? Why is pi actually? Not at what is pi, but why is pi? And now our next part, which is why pi radians is equivalent to 180 degrees, right? Wait a second. Yeah, it's already 26 minutes. It's been already 26 minutes. And now let's just talk about the second part of this video. So that's even more interesting. This was just for the definition, or for someone who don't even know what pi is. This was all the things for someone who don't even know what pi is. So I hope if you didn't have an idea about pi, now you are done with that. Right? Obviously, dude, it's just the ratio of the circumference and the diameter, right? And its approx value, not approx, but exactly, it's 3.1415. But you don't need to just memorize that, right? From now onwards, you can just think about this by your own, right? Okay. So now our question is, why pi radians equivalent actually, or you can say equals oh wait a second, 180 degrees. Okay, now let's just talk about this. So in India, till class 10th, students often learn what is sine theta, what is cosine theta, and what are other 6 trigonometric functions, or you can say other 6 trigonometric functions. And I'm not going to tell you all those things that here, right? Because I think I have made like you can say a fundamental video on trigonometry, like fundamental trigonometry. So it's around 1 hour, or I think it's more than that. So you can consider watching that video if you want to learn trigonometry, right? Okay. But in that video, I haven't talked about why this happens, and even I wasn't thinking about that at that time when I was recording that video. I wasn't thinking about this, and today I just got to think about that why this happens. Like, why do I need to? Like, why did I use this? When I just entered in so basically in 10th till 10th standard you just learn about till 90 degrees, right 90 degrees actually. And when we just enter in class 11th, actually in standard 11th, so we just like actually we study about radian system, right? So I can remember that I also did study this, but I never questioned it. And today, this is, I think, I'm not sure about the date, but I think it's, I think it's 18 or 19th of July. And today, I just got to question this, like, why? Why did I believe this, and why do you believe this? Like, pi, radian, what is radian? It's a system, and degree is also a system. Like you can say it's a unit for angle, right? Okay, so let's just talk about this. First of all, we have studied about pi so far, that if this is a circle and if this is the diameter of this circle and if this the length of this part is c, so pi is c over d, right? Okay, and you know what, in my, like, I think a lot of videos, previous like in my previous videos, I have used, I'm not sure how many times, but a lot of times, that is, sine of pi is 0. But have you ever watched me using this thing? But I've never just did this. You know, like, why this is happening? But now I'm just gonna do that. No, I'm not gonna do that actually. You guys are. I'm sure about that. You guys are doing this. Like, what he's talking about and what. So yeah, okay. But yeah, at the end of this video, you will be cleared out of it. Okay. So yeah. So far we have just learned this thing, right, about pi. Okay. And what's degree? So let's just talk about another circle actually, and this is the midpoint actually. You can say the center, not midpoint. I'm sorry. So degrees. So I just got to know about degrees on Google actually. I was just doing Google. So I just got to know that Babylonians, I think, I'm not sure, the Babylonians, I think 4,000 years ago, they just introduced 360 degrees out of nowhere actually. But at that time, the reason, because the reason was like, actually this part is 360 degrees, and this, if we just divide this, so this part is 180 degrees, right? So basically Babylonians discovered, or you can say used to represent a circle by 360 degrees at the center of it, because at that time there were 360 days in their calendars, right? And maybe like after, obviously, 4,000 years means before Christ. So yeah, if we just talk about some 2000, I'm not sure about the date, but if we just go, if we just come up further in the humanity, so we just got to know that 360 is a good number actually, because it has a fact, or you can say it has a factor of 2, the divisible, 360 divisible by 2, 3, 4, and 5, 6, 8, I think, I'm not sure. Yeah, let me just check this out. Yeah, it's divisible by 8, 9, 10, and 12. So for that case, maybe we just took 360 degrees for the circle, to represent a circle actually. Okay, but then why radians actually? Why pi? Let's just talk about this. Okay. Okay. Now, I'm just gonna tell you the exact reason why this happens on this board. Okay. So first of all, let's just consider a circle of radius 1 kilometer. Right. So consider a track, a circular track actually, of radius 1 kilometer, right? Okay. So let's say that you are here actually, and you have to just move in this direction, and you have to reach at this point actually, which this point will make exactly 90 degrees from it. Like these 2 points would be making 90 degrees at the center, right? So let's say that you just began moving from here and you just reached up to here, and the radius of this track is 1 kilometer, right? Okay, so let's just talk about the pi. So pi was c over d, right? Okay, and what was d actually? So d is 2r, right? So if we just plug this back over here, so pi is gonna be c over 2r, and if we multiply both sides with 2r, so c is gonna be 2 pi r, right? Okay, so everything is fine over there, and we did prove this actually. We are not using it out of nowhere, right? We are just erase that. Okay. Okay, so this is the okay, and for this circle we have radius as 1 kilometer. So basically, when we plug r equals 1 kilometer, so that's going to be giving us 2 pi kilometers. So the circumference of this track, of this circular track of radius 1 kilometer, is exactly 2 pi kilometers, right? So the length of this part is 2 pi kilometers, right? Okay, so if we talk this, look at this. This is known as the quarter actually, right? Obviously, if this is your circle, so this is your full circle actually, and this is your half circle, and this is your quarter circle actually. So this is your quarter actually, quarter part, 1/4 you can say, right? Okay, so this is your 1/4, right? So basically you are covering this part, and we have the length of the full track. So if you're covering the 1/4 of the track, so that's gonna be, if I calculate, if I say that the length of this part is, the quarter is let's say w, right? So I hope you can see that. Let me just check that out. Yeah. Okay. So that the length of the track that you covered quarterly is w, right? So w is 1/4 times the circumference actually, because it's the quarter. So basically we have a calculated circumference here, and this is, if we just plug this back over here, so it's 1/4 times 2 pi, and that's going to be giving us pi over 2. So basically your w is pi over 2 kilometers. Can you just imagine that? Let's say that you are just standing at the edge, at the most edge part of a circular track, and you just of 1 kilometer, radius of 1 kilometer, and you just began to moving on the same on the track actually, and you just reached at a point. If we just join that point to the center and this point to the center, so that the both things are gonna make 90 degrees with each other. So the distance you covered is exactly pi over 2 kilometers, and we just found this value out of this thing which we have proved here. So okay, now I'm just gonna make that figure here again, that diagram actually here as well. So yeah, so this is your part. I do have a chalk actually. Okay, wait a second. Actually, you are not gonna see, but let me just highlight this. So I'm just talking about this part. So this is your quarter part, right? And I'm denoting this with W. And this, your track is 1 kilometer of radius, right? So the angle is 90 degrees, right? And you are covering a distance of pi over 2. So W is pi, wait a second. Right? And the angle is 90 degrees. Guys, just take a pause here. Take a little pause and just have some water, as of I'm doing here. Angle is 90 degrees, right? And the length we are covering in when this angle is 90 degrees is exactly pi over 2. And that is why we, like mathematicians, not me actually, not you, but mathematicians have connected that this is a new system, actually a new system, that is radians. So this is how they connected that 90 degrees is equivalent to pi over 2 radians. So this is how it is. You know what, guys, you won't believe, I'm not gonna admire myself, but I just thought about this by myself. I didn't even read this on any website, on any book. I was just wondering that the distance covered by the guy from here to here is exactly pi over 2, and the angle these two points are making with the center is 90 degrees. And that's how we can relate. Actually, I just thought that's how it's related to pi over 2 radians, actually. Right. And that is why the another thing that I should have asked you earlier, but it's all right. Why only pi, actually? Right. We can denote it with any other like any other symbol, that is alpha, or some any other, like you can say this psi. But why only pi? This is the reason why only pi. Right? It's just you can say it's just a relation, actually, because the distance covered by the guy on this track is pi over 2, is exactly pi over 2, and the angle is 90 degrees, and that is why. And if we talk about here, if we connect this, so this angle is 180 degrees, right? So this would be double, actually, right? So so that's gonna be double of. So this is gonna be your, let's say this is your V, so V is gonna be pi. And that's how we are done proving that pi radians is equivalent to 180 degrees. That's how. And I can surely say that if you are an Indian, I don't mind you are a BTech guy or any other, like doing graduation or a school guy, you have never looked at pi this way, or you have never looked at pi and degrees this way, you have never looked at pi this way before. So yeah, and I think it's done. Let me just check the length of this video. I think it's already, yeah, it's 42 minutes. Okay, so that's the beauty, actually. We need to think about mathematics. Mathematics is not boring, but the way you are learning mathematics is boring, actually, is actually boring. But when you just look at these things, actually, so these are actually beautiful. So yeah, actually, and yeah, it's perfectly fine. And so for now, I think it's fine, but okay, let's just do something a little bit here. Okay, so let's consider another circle here, circle. Okay, and this is your, let's say this is your center. So let's just connect the center with these a little triangles, not perfect triangles because they are not having a perfect base, right? Okay, well, let me just get finished with it. Okay. So why I'm doing that? Each one of these things are representing R, right? So if I'm just gonna divide this in half, and I'm just gonna open it up, actually. So what I'm talking about is, let's just consider this one. So I'm just gonna cut this in like pizza slices, you can say, and I'm just gonna cut this half, right? Cut this clock in half, actually. Okay. So if I'm just gonna open it up, so that's gonna be giving us something sort of this thing, actually. this the lower part actually is gonna be this thing, something sort of this one, right? And the upper one would be adding to this, and that's gonna be giving us to something sort of this one, right? Okay, guess what? Actually, we have just cut it down into halves, right? So basically, the if we talk about the perimeter or the circumference of each one of them, so that is your actually this length is pi r, because dividing it with 2, actually it's 2 pi r, but we have just cut that down in half, so that's going to be pi r, and this length is r, right? Obviously, yeah, this is the length, actually this is going to be r, although it's this point is connecting to this one, right, and this point is connecting to that one, but I haven't just expressed that precisely here, but it's all that you can understand that. So if we consider this as a rectangle here with length pi r and width r, so the area of this rectangle is gonna be pi r into r, which is pi r squared. And that's how we just proved the area of circle. That was quite easy, wasn't that, guys? Should I just explain it to you again over here, or you are done with that? Actually, my marker is finished with ink, so I think it's not that dark, but let me just check whether I can fill some inks into my marker. Yeah, I can. Wait a second, guys, let me just... Okay. And thereafter, I'm just going to explain to you another time, actually, because that was quite fast. So the third part of this video is area of circle, right? Okay. Proof. So consider this as a perfect circle, although it's not perfect, but just consider it. And this is your center. Let me just correct this. Yeah. And now I'm just gonna carefully connect this to here, 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 and so on. If you think it's a waste of time, please just move forward this video a little bit, guys. Okay. So yeah, and all these things, like these lengths are representing r, obviously, because this is the center of the circle, and that's this connecting a line with the center and the edges, all with radius, right? So okay, so now I'm just gonna divide this in exactly halves. Okay, so dividing half, let's just imagine a pizza, right? Pizza. So after just slicing it into pizza slices, so I'm just gonna cut it in half and just open it up. Not perfectly slices, actually, right? Not precise, or you can say fine slices, but at these points it's joined, actually, right? So I'm just gonna open it up, and then what next? Actually, let me just check that you guys can see all the things correctly or not. Yeah, I think everything is fine. Okay. So the upper part is something sort of this, right? Okay. And the lower part is the same thing, something sort of this, and this one, actually, right? And this one, exactly connecting to the ends of these things, right? So okay, so I have just cut down that circle in halves. So first, earlier the circumference of that full circle was 2 pi r, as we have just proved it down over there. So if I have just cut that, cut the circle in half, so obviously we would be dividing like to find the circumference of each one of those half circles. So we just have to divide it with 2. So basically 2 pi r over 2 c each actually. So c each is gonna be pi r, right? So pi r is the circumference of, like, this is your pi r actually. This is, right? Okay, so basically this, I have just opened this up. I have just opened this up, something sort of this. And I have just opened this up as well. So this is your pi r as well. Pi r, pi r. So I have just opened them up, and I'm just gonna, I have just combined them, upper and down. So this length is pi r, right? And this one as well. Because I've just opened this up and I have just converted this into something sort of that. And this part is just the radius actually. So this is your radius, right? So basically what you are having is a rectangle of length pi r and width r. And you know, the area of a rectangle is length times breadth, width actually. So we have length as pi r. So basically area is pi r times r, and finally we have pi r squared, area of the circle. We are done with the area of circles. And what is pi and why like pi radian is 180 degrees. So I think guys it's enough. It's already 51 minutes, I think 52 minutes ongoing actually. And yeah, I think we got to learn a lot of things, and I'm sure about that actually. I did a lot of work over here for you and for myself as well, right? And again guys, right, I'm just requesting you that if you like this video, if you got to learn something out of this video, please make sure to like, subscribe and share, and comment down as well what did you find in this video, how do you like whether you liked it or not, and why you didn't like it or why do you like it, please. And before yeah, obviously if you're watching till here, so you have just done all these things, but please make sure to share all the things that you have earlier didn't know, but you just got in this video and then you learn about that thing. Please make sure to tell me that yeah, you didn't know about this thing, and when I just got into this video, I just got to learn this, right? And again guys, if you have any kind of doubt so far, you are free to ask me in the comment section. I'll be there to reply over your questions. And goodbye guys, take care, love you, and just learn mathematics. Actually visualize mathematics, because when you visualize it, you will be seeing that yeah, it is beautiful, it is extremely beautiful, right? And yeah, I think it's fine. And just love mathematics, learn mathematics, love your life, love each moment of your life, and because you are just having that only moment. This is the only moment that you are having, right? You cannot do anything with your past. That is the 1 second which just passed, right? You cannot do anything with that, and you don't even know what's the next upcoming second is. And whatever you have got, whatever you have right now is your present actually, this very second. So for that case, just enjoy and love whatever you want to do. Actually, no, do whatever you want to do actually, right? And yeah, and I'm a mathematics lover as well as a philosophy lover. So that's all. You have noticed me. You must have noticed in me that yeah, I'm just explaining you mathematics, and simultaneously I'm just talking about philosophy. So okay, it's all right. It's fine. and goodbye. I'm sorry, not goodbye, but goodbye, guys. Take care. Love you. And yeah, just come up in the next video, because these type of videos you can find here only. And yeah, goodbye. Love you. Wait a second. Let it be 55 minutes. 58, 59, and done.